Alright, hi everyone. So this is the third lesson for our topic 7 factors in Pure Maths 3. So as usual, let's start with the learning outcome of today's lesson. Okay, so after today's lesson, you'll be able to understand the significance of all the symbols used when the equation of a straight line is expressed in the form of vector r equals to vector a plus t vector b. Okay, so let me try to explain a bit before I move on. So we know that previously when we try to talk about equation of straight line, right, then the first thing that you have then, for example, you know that y equals to mx plus c. So we know that the x and y here represent a coordinate, then the m here is the gradient, then the c is the y-intercept, right? So it's the same thing here, but today we are going to look at like a new form of equation of straight line, which will be expressed in the form of vector. So this is like the formula that we are going to learn. So you are going to understand what is represented by all the symbols here. So after we understand that part, then we'll be able to use the information that given by the questions to actually create or to find the equation of the straight line by ourselves. Okay, so which means that in short, the main focus of today's lesson is to understand the vector equation of a straight line. Alright, so let's start with the intro. Alright, so let's start the lesson. Yeah, so all this while we always represent a line by using Cartesian form, right? So which means that we try to put it in like a coordinate geometry form. Then if it's in a 2D space, then normally we will have like two formula that we use for us to find the equation of straight line. Then it will be the first one like the y equals to mx plus c, or we also learned that y minus y1 will be equal to m then x minus x1, right? Or sometimes you'll write in a general form, which means things like ax plus by equals to c. Okay, so in 3D space, we actually didn't learn like how do we actually find the formula of it, but we know that it will be in a form of ax plus by, and because we have like the third axis, right, so that's why we also have cz, then it will be equals to d. Okay, so this is like the equation in a Cartesian form. So in today's session, we are going to learn how to write an equation in vector form. So in short, it's called as the vector equation. So a vector equation of a line is a way of expressing the position of the vector of any point on the line itself. Okay, so yeah, so we are going to look at the idea of how do we create this vector equation. All right, so yeah, to form the vector equation of a straight line, we'll need two things. So the first one is we will need to know a point on the line. So a point on the line. So in this case, we'll try to denote it as A. Okay, so A is a point that we already know on the line, so that's why the coordinate is represented by maybe A1, A2, and A3. Okay, then the second thing that we need to know is we need to know a direction vector. So later we'll be explaining what does that mean by a direction vector here. So a direction vector will normally be denoted by B. Okay, so this direction vector must be parallel to the line. Okay, which is parallel to the line. Okay, so let me try to explain this idea by using a diagram here. So I have a straight line. Okay, so let R be any point on the line that we want to find its equation. So perhaps I just assume that my R is here. Okay, but obviously R is a point, like for example, you have y equals to mx plus c, the xy can be any coordinate, right? As long as we substitute the correct x, then we get the y. So that's the similar idea. So the R here is the unknown point that we want to find the equation. So we have the x, y, z here. Okay, so when we want to find this R thing, then which means that I need the first information here, which I need to know a point on the line. So if let's say this is a straight line that I want to find its equation, I'll need to know one point on the line. So for example, this is the line that I know, and it's denoted by A, which with the coordinate of A1, A2, and A3. So now, since they are in a 3D plan, right? So which means that I will have one origin also. And if let's say I try to connect O and A together, then I'll be able to get the position vector for the coordinate A, right? Which will be denoted by OA, or we try to write the vector A. Okay, I hope that you are following me. Then after that, the same thing, if I try to connect O and R together, then I'll be able to get the position vector of R, which will be denoted by OR. So OR is here. Or sometimes we try to denote it like R. Okay, so we know that if let's say by using the law of addition that we have learned previously, right, for us to find what is the coordinate x, y, z here, which means for me to find the position vector for OR, what do I need to do? I will need to do OA and then plus AR, correct? Okay, but what is a problem here? Because OA, I mean, of course, if let's say I know the coordinate of A, then I'll be able to find OA. But a problem here is R is any point on this line, right? Which means R can be here, can be here, can be here, can be here. And it's an unknown point. It's like a general point that we want to find on the line. So which means that we do not have the R. So how are we going to find the AR here? So this is why the second piece of information come in, which is called as the direction vector B. So the direction vector must be a line that is parallel to the line that we want to find. So for example, this is my B. Okay, so as you can see, it's parallel to the line of AR, right? Okay, but then why is it called as a direction vector? Okay, let me try to explain it with another color here. So just now we say that R is a general point on this line, right? Which means R can be here, it can be here, it can be here, it can be here, or even if I try to expand this sign, then R can be here as well, right? Because it's a straight line, right? So R is any point on this line. It's like can be any coordinate of x, y, z. Okay, so now why am I taking consideration of B? Because I only want the element of the direction vector B only. Why is that so? Because if let's say my R now become here already, then my OR can be here and my OR can be here. So you can see that I will still be using the OR, the vector of OR, and here will still be OA. But the AR here, what is going to change? The direction is still the same, but the magnitude of the vector is going to be changed. So that's why in another words, for us to find AR, how can we find it? So it's by using OA and then plus, we know that if let's say one line is parallel to another line, so if let's say vector P is parallel to the vector Q, then normally they can be written in the form of P equal to KQ, right? And K is like a scalar, so which means like the magnitude thing. Okay, so that's why the same thing here, AR will be equal to, so in this form we will try to take in the parameter of T, so which means it's the scalar of the vector B here, so TB. Okay, so let me try to draw this again. So which means that if let's say now my B is going to be controlled by the scalar T here. So when I use different scalar to multiply my vector B here, right, the position of R can be changed. So if let's say my original B, the magnitude is like this. So which means, for example, when I try to put, if let's say the scalar is 1, which means that I'll be able to get R is here. So if let's say now the R is here, then what am I going to do? If let's say this is like 3 times, which means that I'll draw 1, 2, 3. So the T here will become B. So if let's say I'm going to be the negative part, so now then maybe my scalar will become -1. So if I go further, then maybe the scalar will become 5, 10, and so on. So that's the idea of the scalar T here. So that's why when we try to simplify this, then we will be able to get OR will be represented by the vector R equal to OA represented by A, and then plus T is the scalar, and then B is the direction vector that we want to put in here. Okay, I hope that you can roughly understand this idea. Okay, so let us try to put into the notes here. So which means that the vector equation of a straight line is equal to R equal to A plus TB, where the straight line will pass through a point and the straight line will have a known point which we can find is position vector, which will be denoted by A. Okay, and this straight line is going to be parallel to the direction vector B. Direction vector. So if let's say I try to put it in words, right? Basically how this formula works is that R is basically like a random point on the line that we want to find, right? So the basic structure will be equal to the general point on the line. Then after that, it will be equal to, what does that mean by the A here is the position vector, right? So the position vector will be a point that you already know on the line. So that's why it's going to be the position of a known point. Then after that, what is the B here? So the B here is the direction vector, right? But we need to times the T here. So why is it the T here? Because we do not know that how long that we need to stretch for us to find the R there. So that's why it's going to be like some way. So some meaning that we don't know what is it. So some way along the direction B. So along a known direction. So that's like the idea for the equation here. Okay, so don't worry, it might look a bit complicated here, but later when you are trying to look at the questions, then you'll understand better and you'll realize it's actually not that difficult. The idea is you need to understand what does that mean by the RATB here only. Okay, so there are a few notes that I put in here. So the direction vector B can be any magnitude. The idea is that it must be a vector that is parallel to the line only, because what happened is the magnitude will be decided by the vector T. Yeah, you remember just now when I tried to use the green color thing? Yeah, so if let's say I'm trying to, instead of like this red color, right, I'm using a magnitude of like this long. So it can be also, it's just that for me, so just now for me to reach the R here, I will need 3B. So if let's say I put this length, then maybe I will need 1B for me to reach R. So which means the magnitude will eventually be decided by the T that we have. So which means that the magnitude of the vector, of the direction vector is actually not so important, because the magnitude can always be decided by the scalar T there. Okay, then the second thing is the value of T will be positive for the points that on the same direction. So which means that if let's say this is the direction of our AR, right? So any point that on the left hand side of the A, you will actually get a positive T lah, a positive scalar. So if it's in the other side, which means that you'll get a negative scalar, which enable you to go to the opposite direction. Okay, so that's the idea. All right, so before we move on to look at like few example for the equation of a straight line, I'll just use some time to just finish this short part for the parametric form for a straight line equation. Okay, so just now we say that R, X, Y, Z represent any point on the line, right? So the position vector for the point can be written as OR. Okay, so OR also equal to R, and it will be represented by X, Y, and Z. Okay, so if let's say you want to write in I, J, K also can, then it will be like XI plus YJ plus ZK lah. Okay, so since we know that R equal to A plus TB, right? So which means that when I try to write it in a column vector, then what do I get? for the x, then it will be the x, y, and z. So equal to the vector A is a known point that we already know, which is denoted by A1, A2, and A3. Okay, so plus T is the scalar and B is the direction vector, which means that we also know what is the B1, the B2, and the B3. Okay, so this is like how the vector equation will look like. Okay, so if let's say you want to write it in ijk, then it will be in the form of xi plus yj plus zk. Yeah, so obviously you can see that column vector is easier to see, and then I mean it's not so long because you don't need to repeat the words like ijk there. Yeah, so but then yeah, I'm just writing it to show you that they are actually the same thing. So a1i plus b2j, sorry, plus a2j plus a3k, and then plus t, and then b1i b2j plus b3k. Okay, so after that, let us try to simplify the equation over the right hand side. So which means I'll be able to get x, y, z will be equal to, so a1 plus tb1, okay, a2 plus tb2, sorry for the noise of the motorcycle, okay, a3 plus tb3. Okay, so from there, so the same thing for the ijk, when I try to simplify them, then I'll be able to get xi, yj plus zk. Okay, then it will be equal to, so let us try to simplify the left hand side, the I and I together. So I'll get a1 plus tb1i. Okay, then a2 plus tb2j, and the last one a3 plus tb3k. So don't worry, I mean the column vector and the ijk, the component form is actually doing the same thing. I'm just going to show you like both way. Yeah, okay. So when we try to compare the components, right, I and I, j and jk and k, or like in terms of column vector, then we'll be able to get like three equations. So x will be equal to a1 plus tb1, and y will be equal to a2 plus tb2, and z will be equal to a3 plus tb3. Okay, so this equation is called as the parametric equation of the line. So just like that. All right, so yeah, meaning that the new thing, the more important thing will be still at the part where how do you create a vector equation. So after you be able to create the vector equation, then you should be able to create the parametric equation as well. All right, so now let us try to look at like the few example over here. All right, question one, write down a vector equation of a straight line that go through the point 3, 1 with a direction vector 4, -2. Okay, so by using the basic structure that we have just now, so which means 3, 1 is the known point that exists on the straight line. Then you have one direction vector which is parallel to the vector of the straight line that we want to find. Okay, so that's the idea. Okay, so when you try to write answer, right, sometimes when you look at some book, they will try to use A and B. But when you try to look at your textbook, I think they try to write in the way of like the known vector equal to what. Okay, so for example, if let's say you try to write it in words, then it will be written in the form of like the known point is equal to, so you have the 3, 1, right? So which means that we'll need to change it into a vector, in a vector form. So which means if let's say the point here is A, then the OA will be 3i plus 1j, right? So the known point here is like 3, 1. Okay, then after that you have the direction vector here, so which means the direction vector will be equal to, then you have the 4, -2 here. Okay, so after you get this, then you are just going to put it in the vector equation. So which means that vector r will be equal to a plus tb, right? So a is the known point, So that's y, 3, 1, and then plus t, and then 4, negative 2, and you have the r here. And just like that, then this is the vector equation. All right, yeah, as simple as that. So sometimes when you look at some book, they wouldn't be able to just write like the known point or the known direction. They will just straight away to use A and B also can. But the only thing is maybe, I mean, if let's say you are not having like a point of A, the question already try to denote to you like it's like Q or PQ, then you need to try to denote and write that this variable represent what by yourself in the question itself. Okay, so let's try to look at example 2. So this is a 3D form, but actually the idea is the same. So the line passes through a point with the position vector. Yeah, so this is like the known point that we have just now. Then after that is parallel to the vector of I minus j plus k. Okay, so A, find the vector equation of the line. So since the question gives us in terms of ijk, then we can give the answer in ijk as well. So which means that in this question, the position vector which represented by A is given that 3i plus 2j, sorry, minus 2j, and then plus 4k. Okay, and the direction vector, because it's parallel to this vector, right? So which means the B will be equal to I minus j plus k. So for the vector equation, we are just going to put into the equation A plus TB. So now let us substitute. So 3i minus 2j plus 4k plus t, and then I minus j plus k. Okay, so you can just leave your answer in this form. Or if let's say you want to change it to column vector also can, which means that you will be able to give your answer in like 3, negative 2, 4, and then plus t, I, negative, sorry, 1, negative 1, and 1. So they just mean the same thing. Okay, so B, find the parametric equation of the line. So which means that we need to write the three equations like how we did just now. So we will try to let the R be x, y, z. Okay, so let us try to simplify it. Then we'll be able to get x, y, z. It will be equal to negative 3 plus t, negative 2 minus t, 4 plus t. So remember to just simplify and then try to write it in three equations. So x equals to negative 3 minus t, y equal to negative 2 minus t, and z equal to 4 plus t. And that is your three parametric equation. All right, so next one, example 3. Okay, so number 3, find a vector equation for the line that passes through the points L and M, which given 1, 2, and 5, 3 as the coordinate. Okay, so now we have some problems here because we know that for us to form the vector equation, we need one known point and the direction, right? But the problem here is we have two known points, but we don't have the direction. So we need to find it out ourselves, okay? So which means that for the first time, or when we try to explain it, then what you can try to do is to try to draw a diagram so you understand what is it actually happened here. Okay, so which means that I have this line. So I'll just let this point be the L and this point be the M. Okay, so both of these point is actually on the line. So which means that the known point can be L, the known point can be M as well. So which means that when I try to expand this sign, then I'll have this is the R, which means the general point on this line. So same thing, I have my O here. So this is the OA that I want to find. Sorry, the OR. So if let's say in this case, I wish to use L as my known point, so which means I'll try to connect these two together. Okay, so since I use L as the known point, so which means that in this question, my A is going to be the vector for OL, right? Because this is the position vector on the of the one point that I know. So in this case, then I'll be able to get my first vector, which is 1, 2. So my problem here is with the direction vector. So I need to have a vector that is parallel to this sign. So since it's not given this B direction, so which means that we need to find the direction by ourselves. So what you can do, so you can see that LM, so we want to find LR, right, for us to actually get OR, because OR equals to OL plus LR. But the problem here is we don't have LR, then normally we try to use KB to represent LR. So, but since we do not have the B here, which means that can we try to use LM? Yes, right, because it's a line that is parallel to the line that we have as well. So that's why my direction vector in this question is basically going to be LM. Okay, I hope that you're following, because LM is basically the same thing like when I have another direction vector lah. Yeah. So for LM, then can I find it? Yes, I can, right? Because I can use LO to plus OM. Okay, because I'm given the position, the coordinate for M as well. So that's why LO will be equal to -1 and -2. Okay, LO is the opposite of OL. Then plus the OM here is 5, 3. So from here, then I'll be able to get 4 and then 1. So which means that my B in this question is going to be 4, 1. And obviously LM is just here. So the R can be here, the R can be anywhere. So that's why we need the scalar there. So it's the same thing. So which means that R equal to A plus TB. So that's why in this question, we will have the answer of 1, 2, and then plus T, then 4, 1. All right, so just like that. So you might have a questions that because the M here is on the straight line as well, so can I use OM as my A instead of OL? Yes, you can. But I mean, for the easier way, because we have LM and we know that by looking at the coordinate, then we know that L is on the left hand side, then M is on the right hand side, right? So if let's say you want to do, then maybe the position that you want to find, then it might become ML. But the answer can be accepted as well. So which means both can be accepted, no matter you are using LO here or you are using sorry, it should be here. No matter your A is OL or OM, it can be accepted, because the idea is that you need to have 1 point on the line only. Yeah. So which means that the other alternative that you can have is like 5, 3 and then plus T. So the parallel vector is still going to be the same, right? So T for 1. Yeah. Okay, so that's the idea. All right, so let's continue to number 4. All right, number 4. So points A and B has position vector of 3, 1, -4, and -2, 5, 0 respectively. So find in terms of vector form the equation of a straight line passes through A and B. Yeah, so it's the same idea like the previous question just now. So which means what we can try to do is you can try to draw it first. Yeah, so that's the idea that you can understand better. So let A be here, then B be here, and this is your R. So same thing, for an easier course, we just try to use the first point here lah. So which means we have the origin here. So OA and then AR, sorry, OR. So which means for me to get AR, then I'll be able to use one vector that's parallel to it. In this case, then I can use AB. Okay, so that's why in this case, my A, the position vector for a known point, it can be OA, which is given 3, 1, and -4. So my position vector B, it can be by using AB. Okay, so which in this point, I can find it by using AO plus OB. All right, so AO will be equal to -3, -1, and 4, and then OB is -2, 5, and 0. So from here, then I'll be able to get -5 and 4 and 4. All right, so this is the vector that is parallel to the line that we want to find. So now we can try to put into the vector equation. So R equals to A plus TB. Okay, so equal to my A is 3, 1, -4, and then plus T is -5, 4, 4. All right, so that's the answer for A. So B show that the points C of -12, 13, and 8 lies on this line. So it's the same thing like if let's say you are given an equation of straight line and you want to find whether this line can fit or not, which means you are trying to substitute in the equation, then you will see whether it's satisfied or not. So it's the same thing over here. So what we can try to do here, we can assume that it's satisfied first. So what we can try to do here is the r is the point, right? So which means we try to let it to become negative 12, 13, and 8. Because r represent the position vector of any point on the line. So since c is on the line, which means c must be able to satisfy in this place. So that's why equal to 3, sorry, here r. Yeah, make sure that you remember to write the r because this is supposed to be a complete equation. So 1, negative 4, and then plus t, negative 5, 4, 4. This is how parametric equation come in to help you to solve the question. So you'll be able to get negative 12 plus 3 minus, sorry, negative 12 plus 5. Okay, so I'm sorry, give me a minute. Yeah, so negative 12 will be equal to 3 minus 5t. Okay, then I have second equation here, which is 13 equal to 1 plus 4t. Then after that, I have 8 equal to negative 4 plus 4t. So from here, when I try to solve it, then what do I get? I get 5t equal to, yeah, this is not a good way of writing it up because, yeah, I do not have enough space here, so that's why. So 5t, then after that equal to 3 plus 12. So from here, then I'll be able to get t equals to 3. So same thing over here, then I can get 4t will be equal to 13 minus 1. So I also get the same answer, which t equals to 3. So same thing, I'll need to check for the last one because we need to make sure that all the t is the same, which means when you try to substitute t over here, then you'll be able to get this three number. Then only this point is on the line. Okay, so 4t will be equal to 8 plus 4, so which means it's 12 as well. So divide by 4, then you get t equals to 3. Okay, so which means solving all the equation gives t equals to 3. Okay, so from here, so if t is the same, which means the three equations are consistent, right? So that's why c, negative 12, 13, and 8 lies on the line. Okay, so if let's say when you try to solve it, right, then you get one number is different, then which means that it's not on the line anymore. Because if let's say, and what is that called? Just a example. So if let's say this, I try to change it to, let's say I try to change the 8 to be like 7, to be 12 maybe. So what do you realize is that when I try to solve it, then I'll be able to get like 12 will be equal to negative 4 plus 40. So when I solve it, then I'll be able to get 4t equal to 16, then t equals to 4. So the idea is that when you substitute 3, right, then you should be able to get like the coordinate of 8. But now you are getting 12. So which means 8 is not the same with 12, so it's not consistent for the t here. So if let's say you found the t is 4, right, then when you substitute 4, then you wouldn't be able to get negative 12 and 13. So you know that these three numbers cannot exist at the same time. So obviously it's not on the line. Okay, so that's the idea of it. All right, so that's it. So let's try to look at the next question. All right, number 5. A line has a vector equation given by vector r equal to 3i plus j plus k plus mu 2i minus j minus k. Okay, show that this line intersect x-axis. Okay, so this question is similar with question 4 just now, but just now it's given your, what is that called? Your coordinate, right? But in this case, they just want you to prove that this line intersect your x-intercept. So to let you guys know that like in a 3D plan, right? So we have like the y and the x over here and we have our z. Okay, so when we try to talk about like a straight line, then obviously no matter where is it, but a straight line will definitely intersect your x-axis and y-axis in a straight line in like a 2D plan. But in 3D, it's not necessary that a line will intersect the x, y, and z axis. So this is the thing that we need to prove. So the idea will be the same. So when we have a 2D plan, right, when we try to say that the line intersect the x-axis, what does that mean? It means that we want to find the x-intercept where what is the x coordinate when my y is 0, correct? So that's why it's the same thing. So which means that in 3D, so if let's say the line intersect x-axis, what does that mean? So it means that intersect the x-axis, it means that the y and the z, it will be equal to 0, which means the coordinate for the x and the z will be equal to 0, which means like the point is at here. I want to find the intersection point over here, which means that there will be uh, zero translation, yeah, in terms of j, and zero translation in terms of z. So it's only on the x-axis. So that's why the line intersect the x-axis. So which means that we need to prove that we can find a point that with a x coordinate, and for the j and k part is going to be 0. So let the point be A maybe. So let the point be A. So what is the position vector for A? So we want to find the coordinate for j, right? So maybe we just try to put an A here. So it will be equal to AI, so which means the position vector for this point. It will be equal to AI plus, then the j will be 0, and the k will be 0 as well. Okay, so which means I need to prove that when j and k equals to 0, I'll be able to get one number that represented by the A here. So how am I going to do that? Then I'll be using the formula here. Yeah, because the R is the general point on the line. So which means I'll need to prove that the point is on the line and the point is intersecting the x-axis. So which means I'll try to put in, so AI plus 0j plus 0k will be equal to 3i plus j plus k plus mu, and then 2i minus j minus k. Okay, so let us try to simplify a bit over the right hand side. So the I and I together, so 3 plus 2 mu I plus 1, yeah, 1, and then minus 0, so 1 minus mu j, and then plus 1 minus mu as well for k. Okay, so which means the first thing that we need to prove that is it the j and k will be the same when we substitute the same mu first. So which means I'll be able to get three equations here, which A equal to 3 plus 2 mu, and then after that 1 minus mu equals to 0, and after that 1 minus mu equals to 0. So these two equations should be able to give me that mu will be equal to 1. So they are consistent. Then after that, I can get my A, right? So A will be equal to 3 plus 2. Then I substitute my 1. Then I'll be able to get 5. So I know that there is a point that with a position vector of 5i plus 0j. So which means my OA here will actually be 5i plus 0j plus 0k. Okay, so from there, then I'll be able to know that A is on the line and it's on the x-axis. A is on the line and on the x-axis. Okay, and that is why the line intersect x-axis. I'm sorry, I should leave more space to my working. Intersects x-axis. Okay, all right, so that's the A part. Yeah, so now let's try to look at the B part. Yeah, so we'll need more space here. I'll try to squeeze this here. I guess I can do it. Okay, so yeah, this is the A part. Let me try to erase the picture here so I'll be able to work out the B here as well. This is A. Alright. Yeah, B is shorter, so no worry. So let me try to use another color. Okay, so B. So the point P lies on this line and has a coordinate of -5, A and B. So the question one is to find out A and B. So it's the same thing lah. You need to understand how this thing works. So same thing, we might need to find out the mu first. So let us try to put it in. So which means that the position vector OP here, it will be equal to -5I plus AJ plus BK. Okay, so same thing, we try to create the parametric equation, but first we try to put it in first. Maybe here I'll try to write it in column vector because I do not have enough space, but if you can, then try to write IJK lah, because that's given in your question, right? Yeah, I'm using column vector because of I do not have enough spaces. Okay, so -5 and AB, it will be equal to your 3, 1, and 1 plus mu and 2, -1, and -1. Alright, so from there, then I'll need to find out the mu first. Then after that, I'm going to substitute the same mu. Then I'll be able to get my A and B. So -5 equal to 3 plus 2 mu. So I get 2 mu equal to 8, and that enable me to get mu equal to 4. Alright, so is it 4? -8, -4. Okay, so because of the parameter must be consistent everywhere, so which means that A will be equal to 1 plus -4 multiply -1 as well. So I'll get 5. Okay, so same thing for B. You realize that it's the same. So plus -4, -1. Okay, so from that, then I'll be able to get 5 as well. Alright, so that's this question. Or the other way of writing this is, if let's say you don't want to answer like this, right? After you get the parameter, then you can straight away substitute inside. So which means that the alternative of writing this is that you can do -5 AB equal to 311 because we have our mu already, right? So plus, then you put -4 here, and then 2, -1, -1. Okay, so just calculate lah. So -5 AB will be equal to, so you can see 3 plus -4 times 2, then you get -5. So times, then you get 4, so you get 5, 5 here. So from here, then you'll be able to get A equal to 5 and B equal to 5. So both can be accepted. So just depends on which approach that you like to put. Alright, okay, so let's look at the very last question. Okay, the last question. So the vector equation of the line L1 is given that this vector equation, yeah, because you can see this is the A, then the T here is represented by the lambda, then over here is your B, the position vector. Okay, so A, the line L2 is parallel to line L1. So this is the first information. Then the line L2 passes through the point A. So the question wants you to write down the vector equation of L2. So the same thing, we know that for us to create a vector equation, you need one known point and you know the direction, right? So which means in this case, you have the point already, which we can denote it as A. So it will be equal to the position vector for OA, which is 2J and 5K. Okay, so we can straight away ignore the 0 I is totally fine, but just make sure that you don't confuse yourself with the I and J here. Okay, then after that, the same thing, we might need to have the B, which means the direction vector. So since it's already given that L2 is parallel to L1, which means that both of them is in the same direction. So which means we can straight away get the direction from the vector equation for L1. So which means in this case, the B will be equal to I minus 8J plus 5K. Okay, so same like this. So yeah, if you want to write down, like in case next time when you want to do revision and so on, you can just write down because it's parallel to L2 for L1, so which means the direction is the same. Okay, so which means you'll be able to use the same direction vector. Okay, so yeah, you have all this information already. So now you can try to put into your line of equation. So R equal to A plus TB. So equal to 2J plus 5k plus t, and then I minus 8j plus 5k. Alright, so that's your equation of the line for L2. Okay, B, find the angle between L1 and the line R equals to 4I plus 3J minus 2K, blah, 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 and so on. Okay, so yeah, this go back to when you saw the word like the angle between what, so you should be able to recall the thing that we learned in the previous lesson, which is the scalar product. Okay, so which means in this case, we might need to find out okay, so you see, the idea for the angle, right? Do you think that because when we try to talk about the equation here, it's not the same thing like when we try to talk about a simple vector, because this is like the equation of a straight line. Then it consisted of like the two parts here, and we do not have the mu. So how are we going to decide that? Am I going to take the position vector, which is the A, or am I going to take the direction vector, which is the B part? So this is a interesting thing to think about. So maybe you can pause and try to think for like 2 minutes and so on before you look at the answer here. Yeah. So the idea is that you you can try to ask yourself. So when we try to talk about the angle between two lines, right? Which means if let's say I try to put like this is the L1 and this is the other line that I have. So if let's say this is the angle that I want to find, so my question is, do you think that the direction is important or the magnitude is important? Which one is going to change your answer? So if you are going to use the position vector, right, then what happened? You are not finding the right direction, correct? Because if compared to the, okay, this is the line that we always have, then this is the OA, correct? So this is the A part. And after that, this is our equation of the line, which is the R part. So we have another part, which is our B that is parallel to this. Okay, so my question is, if let's say you are using the A part, is that going to be the same line with the equation of line that you are drawing? No, you are eventually having the direction of the line like this already. But now what happened here is that I want to find the angle between the line. So which means that what is important here, the direction is important, correct? Because when we talk about the magnitude, right, it doesn't matter that how long I draw this line. As long as I have the same direction, then it will eventually give me the same angle over here. You get what I mean? And because of we want the angle of the line L1 and this line, so that's why when we talk about the direction of the line, we are talking about the direction that is the same with the line that is parallel to, which is the B here. We are not talking about the position vector, which we try to use it to help us to get the answer. So that's why in this case, what is the vector that we are going to use here? The first direction will be equal to the direction for L1. So which means that from the line L1, from this vector direction, then I can get the I can get the direction vector here. So we try to use D1 and it will be equal to I minus 8j plus 5k. Okay, then the second one will be able to get it from here. So which means my D2, my direction of the second line, it will be equal to the line that is parallel to this line. So which means it will be from this position vector. So 5I minus j and plus 2k. So this is my vector that I'm going to take it to do my scalar product, so to get my angle. So same thing, let's start with the magnitude first. So d1 will be equal to, I hope that you still remember the formula. So 1 square plus negative 8 square and then plus 5 square. Okay, so I'll be able to get 165 and 25, so 90, yeah. So 3 square root 10. Alright, then the second one, same thing, so modulus d2, so I will have 5 square plus negative 1 square plus 2 square. So from here, then I'll be able to get 25 plus 1 plus 4, so it's 30, and I cannot change anymore. Alright, so after I get this, then I can continue to do the scalar product thing. So d1 dot d2 will be equal to my d1 modulus multiply d2 modulus and cos theta. Okay, so D1, D2, yeah, the component form 1 times 5 plus negative 8 times negative 1 plus 5 times 2. Okay, so more or less we have found it just now 3, 10, 30, and cos theta. So from here, then I'll be able to get 5 minus 8 and then 5 plus 8, 13, 13 plus so 23. So equal to here, I might combine them together. So 10, 30, 90, so oh yeah, 30. Okay, then 10. Yeah, you can just use your calculator to help you to do this. So eventually 300 lah, so 300, so that's why I can take out 10. Then I left 3 inside. So 3 times 10, I get 30. So cos theta. Okay, so cos theta will be equal to 23 over 30 square root 3. So by using your calculator, so we'll be able to get our theta equal to 63.73. Okay, so what is important in this question is to identify that which is a part that you need when you want to do something by using the vector equation. All right, so that's the part of for the example. So please spend some time to finish your exercise, and for next class we'll be able to do a wrap up then to continue the last lesson for the vector. All right, thank you.